The master control relay instruction is used to activate or deactivate the execution of a group of ladder rungs that are fenced between the MCR instruction and the end MCR instruction. When the logic that drives the MCR rung is true, the referenced output is activated and all the rungs within the fence are controlled by their respective input conditions. If the MCR is turned off by the logic, all outputs which are non-latched within the zone are de-energized and execution continues at the rung which follows the end of the MCR. For example, if the input signal auto for automatic is energized, all the fenced instructions are evaluated and their outputs controlled. If auto is off, meaning perhaps a manual operation, then the execution is started at the first rung after the end of MCR instruction. The end of MCR is an unconditional instruction that does not require any driving logic to be energized. Let's see another example of an MCR output. You can recall our startup horn annunciator circuit. Well, we can easily add the fenced part of the program for the control of that line. We simply program a ladder circuit with an MCR right after the horn output and place the control program under the MCR fence control. If the start push button is pressed, the horn will start sounding. At the same time, the normally closed interlock contacts of the horn output will disrupt continuity for the MCR rung, where the processor will jump all the fenced instructions all the way to the end MCR. In this manner, the main control program does not start until the horn has stopped sounding and personnel clearance has been announced. The jump to an address instruction allows the program execution to be altered if certain conditions exist. These conditions being the true or false state of the logic driving the jump to instruction. If there is logic continuity in the jump rung, then the processor will jump forward to the target rung as specified by the label instruction, which must match the jump address. This type of instruction allows the execution of a rung or set of rungs that may need immediate attention. Although this jump instruction is very useful and you will surely use it in control applications, certain care must be exercised when jumping over timers and counters because the order of scan execution is changed or diverted. The label instruction in the target rung destination does not contribute to logic continuity and for all practical purposes is always true. This label instruction is generally placed as the first condition instruction in the target rung. The GOTO subroutine, or jump to subroutine as it is also called, is an instruction which allows the normal program execution to be also altered if some conditions exist. If the logic driving the go sub instruction is true, then the processor will go to the subroutine section which has a label with the same address. The processor then evaluates all the instruction in the subroutine, and when it finds a return from the subroutine instruction, RET, the processor continues with the evaluation of the rung which follows the go to subroutine instruction. This instruction is very useful whenever a routine in the program may be recalled by several sections of the main control program for operations such as mathematical computations, or if the routine may be called on a timely basis for specific functions, such as an interpolation of the nonlinear analog input. Subroutines, because of their use, are generally located at the end of the control program in order to keep better organization of the control software. Sometimes PLC manufacturers may provide you with a subroutine area at the end of your program. The end of scan signal is automatically generated before the subroutine area begins. But if this is not the case, you may want to program a dummy rung at the end of your main control program, directing the label to the end of where the subroutines are located. Each subroutine may be called from the main program, and the return of each subroutine will direct the control back to the main program. The end of scan signal will be generated after the dummy output is evaluated, which is at the end of the subroutine area that you designated.